I'll equip you with payloads, recon strategies, and even teach you to sniff out hack smells that hint at their presence. I'll also be recommending hack-the-box challenges for each vulnerability, ranging from "this is fine" easy to Gru's plan insane level of difficulty. First up, we have injection vulnerabilities. This is when an attacker can send harmful data to your system, tricking it into executing unintended commands. Here's a simple example of an SQL injection where a Flask web application is using a database to store user data. The user route is vulnerable to SQL injection because it directly includes a username from the request parameter into the SQL query. An attacker could provide a username parameter like or1=1, manipulating the SQL query to reveal all users. This is a serious security risk as it could expose sensitive user data. A safer version of this code would use parameterized queries to prevent SQL injection. In this version, the SQL query uses a placeholder question mark for username, and the actual username value is passed separately to the execute method. This ensures that username is properly escaped, preventing SQL injections. To find this vulnerability, look for inputs that are directly used in queries or commands. Payloads often include special characters like single quotes or double quotes to break out of the intended context. Recon strategies include fuzzing inputs and observing changes in behavior. And if you want to practice these vulnerabilities, check out these hack-the-box challenges. Next, we have broken authentication. This happens when session management is improperly implemented, allowing attackers to compromise passwords, keys, or even session tokens. Here's an example of storing passwords in plain text, a big no-no. This is unsafe because anyone who gains access to this file can read all the passwords. This allows an attacker that compromised the system to read it and impersonate the user. Always hash and salt your password. To find this vulnerability, look for weak session management, such as predictable session IDs or sessions that don't expire. Recon strategies include trying to access restricted areas without logging in or after logging out. And if you want to practice this vulnerability, check out these hack-the-box challenges. Moving on to cross-site scripting or XSS, this is when an attacker can inject malicious scripts into web pages viewed by other users. In this code, an attacker could provide a user input like script malicious code, causing the malicious script to run on the user's browsers. Always escape your user inputs. To find this vulnerability, look for inputs that are reflected in the page without proper escaping. Payloads often include script tags or JavaScript event attributes like onMouseOver. Sometimes these attributes can be a part of other tags, like images. For this vulnerability, check these hack-the-box challenges. Next up, insecure direct object references, or IDOR. This happens when an application exposes a reference to an internal implementation object. In this example, the user is able to specify the name of the file they want to access. This is very unsafe because a malicious user would potentially access files they're not supposed to by providing a different file name. Always validate user inputs before using them as object references. To hunt for this vulnerability, look for parameters that directly reference objects, like for example a user ID or something like that. Recon strategies include changing the parameter to another valid value and observing if you can access data you shouldn't be able to. And if you want to practice these vulnerabilities, check out these hack-the-box challenges. Halfway there with security misconfiguration. This happens when security settings are defined, implemented, and maintained as defaults. In this example, the Django application is running in debug mode, which is a security risk because it can expose sensitive information in error messages. Also, the allowed host setting is empty, which means that the application will accept requests for any host or domain. This can lead to security vulnerabilities. The database settings is also a potential security risk. The database credentials are hard-coded into the settings file, which means anyone with access to the codebase can see them. This is especially risky if the code is stored in a public repository. To find this vulnerability, look for unnecessary features enabled or poorly configured security headers. Recon strategies include examining the application's behavior in detail and looking for anything out of the ordinary. If the code is in a public or compromised Git repo, try finding some information there as well. And if you want to practice this vulnerability, check out these Hack the Box challenges. Next, sensitive data exposure. This happens when an application does not adequately protect sensitive information. In this example, a Flask web application is returning user profile data, including the user's password. This is a serious security risk, as sensitive data should never be exposed. A safer version of this code would exclude sensitive data from the response and ensure the application is not running in debug mode. To discover this vulnerability, look for sensitive data sent over unencrypted connections or stored insecurely. Recon strategies include intercepting your own traffic to the application with a tool like Burp or SAP and looking for sensitive data. For this vulnerability, check these Hack the Box challenges. Moving on to missing function level access control. This happens when a function is accessible without proper permissions. Here's an example. In this code, the admin panel function does not check if the user has the correct role. Always check user permissions before granting access to sensitive functions. In this updated version, we have added an if condition to check if the user's role is admin before displaying the admin panel content. If the user's role is not admin, an access denied message is displayed. To find this vulnerability, look for functions that don't check the user's role or permissions. Recon strategies include trying to access restricted functions while logged out or as a lower privileged user. It can be helpful to keep a table of the different types of users and actions that are permitted to these users and roles. And if you want to practice these vulnerabilities, check out these Hack the Box challenges. Next up, cross-site request forgery or CSRF. In a CSRF attack, the attacker tricks the victim into clicking a link or loading up a page that contains a malicious request. This is often done through social engineering and sending a link via email or chat. In this code, an attacker could trick a user into submitting this form, changing the user's password. Always include a CSRF token in your forms. These tokens should be generated automatically by the server and be random for each new user session. This way, the server can verify the request based on this token whenever a new request for this action happens on the server. To test this, you can use a tool like Burp Suite to intercept and modify requests. Try performing a state-changing action, and when you intercept the request, remove any CSRF tokens before forwarding the request. If the action still completes successfully without the CSRF token, the application may be vulnerable to CSRF attacks. A state-changing request is any request that performs an action instead of just retrieving data. This could be anything from changing a user's email address or password to actions like making a purchase or sending a message. And if you want to practice this vulnerability, check out these Hack the Box challenges. Almost there with using components with known vulnerabilities. This happens when an application uses components that are outdated or poorly configured. Here's an example. In this code, the application is using an outdated version of a library. The struts version 1.1 isn't even actively maintained anymore, which means that new vulnerabilities won't get any fixes. Additionally, it already has some major vulnerabilities like an XSS in it. Always keep your components up to date. To find this vulnerability, try to find out what technologies the app uses and how they're configured. There are many tools available for this, such as built-in browser developer tools, command line tools like curl and nmap, and specialized security tools like Burp Suite and OWASP ZAP. And there are even some browser plugins like Webalizer. Once you've identified the technologies used by the application, you can check if they have any known vulnerabilities with a tool like Searchsploit. For this vulnerability, check these Hack the Box challenges. And now we have unvalidated redirects and forward. This happens when an application redirects or forwards users to other pages without proper validation. Here's an example. In this code, an attacker could manipulate user input to redirect users to malicious sites. Always validate redirects and forwards. The isValidRedirectURL function checks if the provided URL is a valid redirect URL based on predefined rules, such as ensuring it starts with a trusted domain. The isSafe external URL function further validates that the URL points to a safe and trusted external domain. Recon strategies for this vulnerability involve identifying places in the application where you can control the destination of a redirect or forward. This could be a query parameter, a form field, or even a value in a cookie or HTTP header. Once you've identified the potential vulnerability, you can test it by specifying a destination of your choosing and seeing if the application redirects or forwards you there. And if you want to practice these vulnerabilities, check out these Hack the Box challenges. Remember, understanding this vulnerability is just the first step. You also need to know how to exploit this. Luckily, Hack the Box has challenges for almost all of them. So make sure to check out the affiliate link in the description below to take your skills to the next level. And hey, if you found this video helpful, don't forget to give it a thumbs up and subscribe to my channel for more informative content like this. Your support means a lot to me. Stay safe, keep learning, and I'll see you in the next video.